In this video, we're going to introduce you to an electronic component called the transistor. Believe it or not, your phone has hundreds of thousands of transistors in it. Your computer has millions. It's not an exaggeration to say that life would be much different today if the transistor hadn't been invented. The name comes from the merging of the two words transfer and resistor to become transfer resistor. Shorten up the two words, and you get transistor. So the name infers that the transistor somehow performs some sort of transfer of resistance. We'll look a bit closer at that concept later. A transistor is an electronic component found in a variety of circuits and is used to amplify or switch electronic signals and electrical power. There are many different transistor types, each with its own electronic symbol. To name just a few, there's the BJT, or Bipolar Junction Transistor. Another common transistor is the FET, or Field Effect Transistor. There's also the UJT, or Unijunction Transistor. A transistor is a semiconductor device. Okay, so what is a semiconductor? Well, in simple terms, a semiconductor is not a good conductor, but neither is it a good insulator. It is somewhere in between. Everybody has heard of Silicon Valley. Well, silicon is a semiconductor, and Silicon Valley is the home of a large number of inventors and manufacturers specializing in silicon-based transistors and integrated circuit chips. The majority of transistors are made of silicon. A small percentage of transistors are made from germanium, which is another semiconductor material. A basic transistor consists of three chunks, or pieces of silicon sandwiched together. As mentioned earlier, there are many different types of transistors. In this video, we'll focus on the bipolar junction transistor, which is probably the most common. A good question to ask now is, what do the letters N and P mean? The first stage of making a transistor is the process of changing the semiconductor conducting properties by introducing impurities into its structure. This conduction change process is referred to as doping. Simply stated, a P slice of the sandwich is more positive, and an N slice of the sandwich is more negative because of doping. Okay. Now we know a transistor is basically a sandwich made of three chunks of a semiconductor material doped to make the P chunks more positive and the N chunks more negative. Let's take a closer look at a bipolar junction transistor. There are two types of BJTs. They are given names based on the doping content of the semiconductor chunks in each. One is called an NPN, and the other is called a PNP. Each has its own electronic symbol. There is a terminal connected to each chunk of the sandwich, and each terminal is given a name. The names are emitter, base, and collector. We are purposely avoiding transistor theory, including the concepts of covalent bonding, the depletion zone, and biasing, as there are an infinite number of websites where you can get that information if you're interested. Just Google any of the concepts mentioned. Here's a couple of tips for you. The arrow is always part of the emitter-base connection. The types can be identified by the direction of the arrow. If we look at controlling a large voltage with a small voltage, we can say that we are performing an amplification. A transistor can do that. The transistor's ability to act as a switch or perform a transfer of resistance makes it a very useful component in industrial applications. Let's look at how a transistor works as a switch. The switch part of the transistor is between the collector and the emitter. The switch is operated by changing the voltage between the base and the emitter. If the input voltage is 0 volts, the switch is open, the resistance is infinite, and the output voltage is plus 10 volts. If the input voltage is plus 10 volts, the switch is closed, the resistance is 0, and the output voltage is 0 volts. There are countless transistor applications. One application that had a huge impact was the invention of the transistor radio. Before the advent of transistors, radios were large, bulky pieces of furniture filled with vacuum tubes providing the required audio amplification. After the invention of the transistor, audio signals could now be performed by tiny transistors. So, the transistor radio became portable and quite small. Transistors are used in industry as well. For example, traditional limit switches are being replaced with active proximity sensors. The output of an active proximity sensor is a transistor switch. With no moving parts and nothing to wear out or break down, the active proximity switch is the hands-down winner over a mechanical limit switch. Incorporating transistors into PLC output modules is another example of where transistors are used in the industry. PLC output modules are now built with transistor output circuits. Early PLCs utilized relay switching to operate loads. Instead of operating a relay, a PLC module can control the output device with a transistor switch. Again, no moving parts, better reliability, and a definite advantage in switching speed. If you want to learn more about limit switches and proximity sensors, check out our other videos called 3-Wire Inductive Proximity Sensor, How to Read the Datasheet, Limit Switch Explained, Working Principles, and How to Wire Discrete DC Sensors to PLC, Part 2. Okay, let's review what we've covered in this video. A transistor is an electronic component used in a circuit to control a large current or voltage with a small voltage or current. The word transistor comes from combining the two words transfer and resistor. Transistors are made of silicon or germanium, which are semiconductor materials. A semiconductor is neither a conductor nor an insulator, but somewhere in between. The most common transistor is the BJT or Bipolar Junction Transistor. The two types of BJT are NPN and PNP. BJTs are used for audio amplification and as electronic switching devices. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.